Hello, this video is on section 8.1, which is titled Adding and Subtracting Polynomials, and the target for this is to classify, add, and subtract polynomials. So the first definition that I want to make sure you guys understand is what a monomial is. And a monomial is basically a real number, a variable, or a product between the real number and the variable that have whole number exponents. So in last chapter we were talking about rational exponents. A rational exponent is a fraction. So you could have 1 over 4 or 2 over 3. These are not examples of whole number exponents. All of these terms down here are monomials. You have a 13, which is considered a real number. The letter z is a variable. Negative 4x squared is a product of a real number and a variable, and your exponent is a whole number. So these are all examples of what a monomial is. Basically think of it as any term that is a product or multiply, as long as it's not plus or minus separating. So you couldn't have like negative 4 plus x squared. That is not a monomial because there is a plus separating the two, when the only thing you can have them separating is a product. Then the degree of a monomial is the sum of the exponents of its variables. Now I made sure variables is in bold and underline, because if you look at the exponents of a number, that does not count as a degree of a monomial. So the first example, 5x, that has a exponent of 1 over the x, so that means the degree of this monomial is 1. Your only exponent is 1, add them all up, 1 by itself is just 1. Then you have exponents 3 and 2 and 6x cubed y squared. So when you add all of your exponents of the degrees together, you have 5. 3 plus 2 is 5, so that's the degree of your monomial. And this last one, since there is no variable in this monomial, it's just 4, that means it has no exponent, or the degree is 0. So there is a difference between this first one, 5x, and this one, 4, because there is no variable or no letter listed in the monomial. So that means the degree of the monomial is 0. When you want to add or subtract any two monomials together, you have to combine the like terms together. And looking at that in comparison to, like if you go back to the last example, you have 5x and let's say plus 4. These are not like terms because this one has an x and that one does not. It's like adding apples and oranges. So you cannot combine those like terms together. But let's say if this was a 4x, then you would be able to add up the like terms together and you would have a 9x. Now, when you have a like term with a degree of a monomial, that must have the exact same degree. So if this was, I'll use a different color here, let's say 5x squared plus 4x. Those are not like terms because they do not have the same degree. This is a degree of 2, and that's a degree of 1. You cannot add those together, and they are not like terms. If you can add them up together, or even if you couldn't, there's created what's called a polynomial. And a polynomial is a monomial or a sum of different monomials. So this expression up here in brown is a polynomial because it's a sum, or it could even be subtract, of two different monomials together, whether they have the same degree or not. Or even just a monomial by itself is considered a polynomial. It's just has one term, but it's still considered a polynomial. Now when you're writing the polynomials in standard form, I guess I should write this, the degrees must start highest to the first and then decrease going from left to right. That's just taking the exponents of all of the variables and making sure the biggest are on the left. So let's say if we have 6x cubed y squared from the very first example, your degree right here for this one is 5. So that means any term that you have after this in the polynomial can only have a degree of 4 or lower. So let's say if we have a term with a degree of 4, it would be x squared y squared. That degree is 4 since they're only being, the exponents are 2 and 2. And then it just keeps going on and on and on and on and on, no matter what your monomials are. Okay, and the last thing I want to make sure we go over is the classification table. Now, this you need to copy down in your notes because looking at some of the degrees and the numbers of the terms within each polynomial, they all have names for them. So if your degree is 0, then it's a constant. And when I say degree, I mean your highest degree. You could have a degree in 0 in all of these, but if you have one that's higher, you look at the highest one. And I only wrote up to 4 because after you go from 4, like when you go up to 5, it becomes 5th degree and then 6th degree, but I didn't want to write that all the way out. You should be familiar with 0 through 4 as constant, linear, quadratic, cubic, and 4th degree. Make sure you understand a quadratic because that's what we're going to hit on most for the rest of the quarter. Is quadratics is a big focus. And then the number of terms, depending on what you have, 1 through 3 have specific names. It's a monomial, binomial, and a trinomial. You probably won't see or have to name any that have 4 or 5, but if you do, then it's just 4 terms, 5 terms. You don't need to know the specific names for those, but make sure you have this copied down in your table because it's going to help a lot when I use some of the words like linear and quadratic and monomial and binomial definitely, and then after that it just becomes a polynomial. Alright, well that's it. Thank you very much.